In this video, we're going to be talking about the cross-elasticity of demand. Okay, so the cross-elasticity of demand essentially measures how sensitive to a change, so how sensitive quantity demanded for one good is to a change in the price of another good. Okay, so the cross-elasticity of X and Y, for example, would be the change, the percentage change in the quantity demanded of good X relative to the percentage change in the price of good Y. Okay, so this is the answer to the question. When the price of Y, it's just, when the price of Y changes by 1%, by how much in percentage does the quantity demanded of Y change by? Okay, and now by now this should have started to feel pretty familiar, right? If you haven't watched my earlier videos on the price elasticity of demand, price elasticity of supply, and income elasticity of demand, I would highly encourage you to watch those videos first to get a full explanation of what elasticity is, why it is that this particular ratio here actually captures the sensitivity to the change in QDX to a change in PY, all that stuff. So that's all explained in previous videos. In this video, I'm just going to take it for granted that you have a general understanding of what elasticity is, and I'll just be defining this new kind of elasticity, right, which is the cross elasticity. Okay, so how do you actually calculate this thing? So this is basically the exact same formula. By now, again, it should be pretty familiar. So you take the, you know what, this is going to get a bit cumbersome. Yeah, we'll just write it like that. Of course, as usual, we take the average of the two, right? And then we're dividing all of this by the change in price. So price of Y2 minus price of Y1 divided by the average. There you go. So that's how you calculate the cross elasticity. Okay, now the definition and the theoretical definition and the mathematical definition shouldn't be surprising at this point. But there is something quite interesting about this concept, which is the cross elasticity, relative to something that we actually explored in an earlier video, which was the difference between a complement and a substitute in consumption. So if you'll recall, right, substitutes in consumption means that when the quantity demanded of one of them, so quantity demanded of X, say, goes up, then the demand for the other one goes down, and vice versa, right? When the quantity demanded of X will go down, then the demand for the other good will go up. In other words, consumers either consume one or the other. They replace one by the other. They're substitutes, right? Whereas complements, right, so I'll put the complement arrows here. Complements in consumption. In this case, the arrows would go in the same direction. So the two goods are consumed together, right? If this is not sounding familiar, just go back and watch my previous video on demand, and I covered substitutes and complements and consumption in that video. Okay, so why is this relevant to this cross elasticity thing? Well, you'll notice that that there is a set relationship when it comes to substitutes between the price of one good and the quantity demanded of the other good. So let's remind ourselves what that is. So for substitutes, so let's keep the same color theme going here. Substitutes will be in blue, complements will be in red. So let's stick with the substitutes. If x and y are substitutes, and again, this is all covered in a previous video, when the price of x, let's say, goes down, resulting in an increase in the quantity demanded of x, then because they're substitutes, right, demand for y will go down. Yes. Okay. So here's our relationship when it comes to substitutes. Let's just cut out this middle guy. So when the price of a substitute decreases, then the demand for that other good decreases. Right? Okay. What about when the price increases? Well, it should be the opposite, right? When the price of x increases, the quantity demand for x decreases, which results in an increase in the demand for y. Right? Okay. So we have the opposite relationship here. Here are our two key relationships. When the price of x goes down, then the demand for y will go down, and when the price of x goes up, then the demand for y will go up. Okay. Now I'm not going to go through this whole exercise again for complements, but the end result would be the exact opposite, right? When the price of x goes down, then the demand for y would go up if the two are complements. And the opposite holds true as well. Okay, now, given these relationships, what can we say about the cross elasticity? Oh, and I should mention, right, that in the previous video, I took pains to differentiate between quantity demanded and demand, right? But of course, let's do that in black. Of course, we all know that when the demand curve shifts to the right, so that's supply, that's demand. When the demand curve shifts to the right, so that's an increase in demand, that will also result in an increase in the quantity exchanged, right? So just keep that in mind in this example, because you might be saying, okay, he took such pains to differentiate between quantity demanded and demanded, and now I'm going, as you're about to see, it's going to seem like I'm mixing the two up. I'm not actually mixing them up, okay? It's just that when the demand for one goes up, right, like in this case, if the demand of y goes up, if the supply doesn't change, the quantity exchanged of y will also go up, right? So when you're observing market data, you're just going to see consumers buying more Y, and you might say, okay, the quantity demanded for Y goes up, right? So just the two are separate conceptually, but for all practical purposes, for this kind of problem here, when we're talking about elasticity, they can basically be treated as the same thing, okay? So don't make the mistake on an exam of mixing the two up, okay? But conceptually speaking, just keep in mind that when the demand for Y, say, goes up, then the quantity exchanged of Y is going to go up. So if I'm an economist looking at data, it's going to seem like the quantity demanded for Y has gone up, right? Just because, it's hard to distinguish between those two, right? So just keep that in mind for the rest of this video. Okay, let's go back to our problem. So we can see something very interesting here. For substitutes, okay, price and quantity move in the same direction. Whereas for complements, price and quantity move in opposite directions. So, what does this tell you about this equation right here? Well, if the equation comes out negative, right? So if this equation comes out negative, that means that the change in price and the change in quantity demanded of the other good moved in opposite directions, right? Because if one goes up, the other goes down. If the other goes down, the other goes up. That means that you'll either have positive and negative or negative and positive, right? Which will result in a negative elasticity. Not less than 1. Sorry, less than 0. Negative. Right? Let's make that super, super clear. Cross-elasticity is nothing but the change in quantity demanded for, say, good X when the price of Y relative to the a change in price of Y. Now, if one of them ends up being positive and the other ends up being negative, or if one ends up being negative while the other one ends up being positive, right? This just means that they're moving in opposite directions. Then, of course, our cross elasticity is going to be negative. But this situation here just corresponds to the situation of complements, right? So, what do we conclude? If cross elasticity is negative, then X and Y are complements in consumption. And if the cross elasticity is positive, then X and Y are substitutes in consumption. Okay, so needless to say, when you're calculating cross elasticities, you also should not be taking absolute values because the signs are actually important. The signs will actually tell you whether the goods are complements or substitutes. Okay, again, I encourage you to go back and to actually explore this logic here, this logic of positive and negative, negative and positive. Again, positive change just means an increase and negative change means a decrease. Okay, so when the change are in opposite directions, then the sum total will be negative. Okay, if that doesn't make sense, again, pause the video, go back in the video, use numbers, right? Insert numbers here, right? A positive number might be 2, a negative number might be -1. This would be -2, right? So then ask yourself, okay, what does this -1 mean? Okay, that means that price has decreased by 1 or 1%. This 2 means that quantity has increased by 2%, right? And of course, this negative means that when the price increases, then the quantity decreases, or the opposite, when the price decreases, the quantity increases, right? So just go through that logic and convince yourself that this is true, because I don't think you should be sort of memorizing this formula here. I always discourage memorization. I think what you should be doing is understanding what this actually means and therefore being able to rederive it on a test, right? If you get a negative cross elasticity, you should be able to say that those are complements. Why? Because the price and the price of Y and the quantity of X have moved in opposite directions. And of course, that should bring you back to this situation here, whose logic you should have already understood from a previous video. Okay, so yeah, that's all I have to say about that. Make sure you understand this whole business of positive and negative here, and what the sign of the elasticity means, and you'll be golden. So if you found this video useful, like it, subscribe to the channel, share with friends and colleagues and classmates. Leave a comment down below if you have suggestions for further videos, and I will see you in the next video.